Hey there, science enthusiasts. Welcome to our channel, where we explore the fascinating stories behind the most groundbreaking discoveries in science. Today, we're going to talk about one of the most life-changing discoveries of the 20th century, penicillin. So, let's get started. In 1928, Scottish scientist Alexander Fleming was working in his laboratory at St. Mary's Hospital in London. He was studying the bacteria that cause pneumonia when he noticed something unusual. One of his bacterial cultures had been contaminated with a mold, which had accidentally fallen onto the agar plate. Fleming observed that the mold had killed off the surrounding bacteria. He named the mold Penicillium notatum, and soon realized that it produced a substance that could kill bacteria without harming human cells. Alexander Fleming was born on August 6, 1881, in Ayrshire, Scotland. He was the third of 4 children to Hugh and Frances Fleming, a farmer and his wife. The family lived on a small farm in Darvel, where Alexander grew up surrounded by nature and developed a strong interest in the outdoors. Fleming's parents were both strong influences on his early life. His mother was a talented musician and encouraged his love of music, while his father instilled in him a strong work ethic and a sense of responsibility. After completing his primary education, Fleming attended the University of St. Mary's Hospital Medical School in London, where he studied medicine and became fascinated with bacteriology. He graduated in 1906 and went on to work as a ship's doctor on the RMS Laurakia, where he served during World War I. Fleming served in the British Royal Army Medical Corps from 1915 to 1918, where he was stationed in Egypt and France. During his time in the military, he developed a deep understanding of the importance of sanitation and hygiene in preventing disease. After the war, Fleming returned to Scotland and set up his own laboratory at St. Mary's Hospital in London, where he began studying the properties of bacteria and developing new methods for isolating and purifying bacterial cultures. It was during this time that Fleming developed his skills as a microbiologist and began working on projects that would eventually lead to his discovery of penicillin. Fleming's discovery was just the beginning. He faced numerous challenges in isolating and purifying the penicillin compound. It took him several years to develop a method to mass-produce penicillin, and even then, he struggled to get funding for his research. Meanwhile, 2 researchers from Oxford University, Howard Florey and Ernst Boris Chain, were working on developing penicillin as a medicine. They faced resistance from many scientists who doubted its effectiveness and feared its potential side effects. Some of the key challenges were difficulty in isolating and purifying the penicillin compound. Penicillin is a fragile and sensitive compound that is difficult to isolate and purify. It is easily degraded by heat, light, and air, which made it challenging to produce large quantities of pure penicillin. Inconsistent fermentation process. The fermentation process used to produce penicillin was inconsistent and prone to contamination, which affected the quality and yield of the final product. Lack of understanding of the fermentation process. At the time of Fleming's discovery, there was limited understanding of the fermentation process and how it affected the production of penicillin. This lack of knowledge made it difficult to optimize the fermentation process and improve the yield of penicillin. Scalability issues. The initial methods used to produce penicillin were not scalable, which meant that it was difficult to produce large quantities of the drug. This limited its availability and made it difficult to distribute it widely. High cost of production. The production of penicillin was a labor-intensive and costly process, which made it difficult for many companies to invest in its development. Competition from other antibiotics. In the early days of antibiotic development, there were other antibiotics available that were less expensive and easier to produce than penicillin. This competition made it challenging for penicillin to gain widespread acceptance. Regulatory challenges. The development of penicillin was also slowed down by regulatory challenges. The British government was slow to recognize the potential of penicillin and provide support for its development, which made it difficult for Fleming and his colleagues to move forward with their research. Fleming's lack of expertise in chemistry. Fleming was a biologist and not a chemist, which made it challenging for him to develop a method for isolating and purifying penicillin. He needed to collaborate with chemists who had expertise in this area. It wasn't until World War II that penicillin finally made its mark on the world. With the outbreak of war, medical supplies were scarce, and antibiotics were desperately needed to treat wounded soldiers. Penicillin proved to be a game-changer, saving countless lives and revolutionizing the treatment of bacterial infections. The impact of penicillin was enormous. It not only saved millions of lives, but also transformed medicine forever. Before penicillin, bacterial infections were often deadly, but with this new antibiotic, doctors had a powerful tool to combat these diseases. Penicillin has been estimated to have saved millions of lives worldwide, including those lost during World War II. It has also been used to treat a wide range of bacterial infections, from pneumonia and meningitis to tuberculosis and syphilis. The discovery of penicillin marked the beginning of the antibiotic era, transforming medicine and paving the way for the development of other antibiotics. It has also led to significant advances in surgical procedures, allowing for more complex operations to be performed. Penicillin has improved patient outcomes by reducing the risk of infection, complications, and death associated with bacterial infections. It has also reduced the need for amputations and other surgical procedures. The widespread use of penicillin has reduced hospitalization rates for bacterial infections, allowing patients to recover from illness at home or in outpatient settings. The discovery of penicillin has contributed to increased life expectancy, as people are now more likely to survive bacterial infections that were previously often fatal. The discovery of penicillin has led to significant advances in medical research, including the development of new antibiotics, vaccines, and treatments for infectious diseases. The discovery of penicillin has also had significant economic benefits, reducing healthcare costs associated with treating bacterial infections and improving productivity by reducing the time lost due to illness. Penicillin has played a critical role in improving global health, particularly in developing countries where access to effective antibiotics is limited. It has helped to reduce mortality rates and improve healthcare outcomes in many parts of the world. The discovery of penicillin has inspired future scientific discoveries and innovations, including the development of new antibiotics, vaccines, and treatments for infectious diseases. And that's the story of penicillin, an accidental discovery that changed the course of history. From Fleming's initial discovery to the challenges and controversies that followed, penicillin is a testament to the power of scientific perseverance and collaboration. Thanks for watching, and don't forget to like and subscribe for more science stories. See you in the next video.